Okay, Assalamualaikum and good afternoon everybody. So my name is Muhammad Zihad. The one holding this camera is Mr. Ami. Alright, so we will run through our experiment for today. If you look in the e-learning, we have our manual. So you can look at the manual while we refer to this manual that I have here. So our title for today is Flight Controller Experiment. This is a very interesting lab because this lab is about how we can build a UAV that is unmanned aerial vehicle that can fly autonomously, and also it can be used for many applications, either for civil or military applications. Right? So about application, you can search in the internet or you can brainstorm by yourself about what it can be used, how it can be used to help people. So we'll go to the introductions. Flight controller, we call it as FC. It's a controller that can be integrated to a subscale aircraft to enhance its capability from a remote piloted vehicles. That means it's RCA planes to an unmanned aerial vehicle. That is vehicle that can be programmed and fly on its own. So with an open source FC, or we call it flight controller just now, users are able to modify or upload custom programs or new build sensor to suit their needs and applications. So if you have your internet, you can search about these programs and sensors. We can put in heat sensors or oxygen sensors to the UAV so that they can search. They can we can do something that is to search less oxygen or more carbon dioxide in the area. So the objective is to learn RPV component in a subscale aircraft. So to start, we have to know about a subscale aircraft. This is RC aircraft. Secondly is to learn the integration of flight controller to subscale aircraft. So when you have understand about subscale aircraft, so we can integrate a flight controller into a subscale aircraft, so it can be a UAV. And thirdly is to understand the benefits of using a flight controller. Right? There are different flight controllers. So it has open source or closed source. We will learn about open source flight controllers for today. So let's go to the equipments. Okay, first we have a subscale aircraft. So Chairman can show about the subscale aircraft here. So a subscale aircraft means it's an airplane that is scaled. Okay, as you can see from left side, this is the right wing. So this is the left wing. So this is the tail parts. Okay, so and this is the fuselage on the left and right. Okay, so this is the subscale aircraft that will be used for today. If you guys are here, you can assemble it. So since we do it online, so we will assemble it for you. Next, we can go to here. So this is the transmitter and receiver. So we call this as a transmitter because it transmits signal to the RCA planes, and this is receiver that will receive the signal from this transmitter to this receiver. So we'll hold this, the pilot will hold this while this receiver is in the airplane. Next is flight controller, that is AutoPilot 2.8. So this is a flight controller AutoPilot 2.8. Alright, so this is the suitable flight controller that is for learnings. Alright, there are many more flight controllers that can be used, but then this is the best. So we also use this flight controller for most of our UAVs. Next is, thirdly is pitot tube. If you guys don't know about pitot tube, so now you can see this is a pitot tube. So this is a tube. It is connected into two tubes to chips over here. So this will be connected to a flight controller. Okay, pitot tube is used to measure airspeed. Right? So airspeed is important for aircraft so that we can know the stall speed, the cruise speed, and everything about speeds. Next is telemetry system. This one. So we have two parts of telemetry system over here. This you can see, this is the FPV radio telemetry air module. That means it will be installed to the airplanes air, and the second part is FPV radio telemetry ground module. So you can see this is a USB. You can connect it to the PC, so it will receive data from the air module. Okay, so the air module will send data to the ground module. That's it. So this is the telemetry module. We'll discuss it later. Next is Dps module. Over here, Jamie. Alright, Dps module. You can see this is Dps module with compass powered by U-block 7M. Alright, we have also on this GPS is an arrow showing that this is the direction for installations. So this GPS, the function of the GPS is to obtain coordinates that will be supplied to the flight controller to the airplane so that it know where it is while flying or on the ground. Next is mission planner software. We don't have it here, but I will show it to you later. So it is a software that you can download it for free from the internet. So you can check it now in the internet, mission planner. So you can Google it, so you can download it. The latest one is 1.3.70 while we record this video. Okay. 7 is lithium polymer battery checker. So this is a lithium polymer battery checker. So this is used to check the voltage of the battery. So another one should be lithium polymer battery. Okay, so this lithium polymer battery checker can be connected to here and it will show the voltage of this battery. So it will showing total of the battery and it's showing the cells 1, 2 and 3. Okay, we'll look at the battery first. So this is not an ordinary battery. This is not a battery that you can see like a everyday or energizer battery. This is actually a lithium polymer battery. They have a high discharge batteries. It is it is rated at 11.1 volts over here. You can, if you cannot see about the glare of the lights, I read it for you. It is 11.1 volts, and it is 3S. Okay, 3S 1P means 3 cells in 1 pack. So if you look at the side, we have 1 pack, first pack, second pack, and third pack. So each pack contains 4.2 volts if it is in full charge, but if it is in minimal charge, it will be around 3.3 volts. So total of 4.2 times 3, that means is 12.6 or 12.7. So that's the full charge of these batteries. Kind to remind you about this lithium polymer battery. We cannot use this battery until 0 volt. So it will be bloated and broken. It will explode. So when we use this battery, minimal value for this battery is 3.3 volts. That's the best. So if we go below 3.3 volts, when we fly, we should land, so that the battery will not reduce to 0 volt on any of the cells. Okay. So again, we have 2 wires over here. This will be connected to the electronic system, and this is the checker. Again, I repeat, you can see this showing, okay, this is the total 12.4 volts, first cell, second cell, and third cell. Okay. Alright, so this is the battery we used just now. We will disconnect this LiPo checker for now and put it aside. And stopwatch, this is a stopwatch that will be used in part 1 later. Number 9, 12 volt to 5 volt converter module will not use in these experiments. Alright, so that's it for the equipments.